Okay, so use what you remember about factoring to factor these expressions. Okay, so in order to factor this, I can use the big X, okay, and I can use the box. That's what we learned last time. Okay, so again, we can use the box. We can put the first term in the first box. And why am I putting negative 16 right here? Because that's the last term, that's our C term, right? Okay, so what's our B term then? 0. So what two numbers can I multiply together to get me negative 16, but add together to get me 0? Negative 4 and 4. Okay, so I got negative 4x and 4x. When I take out the GCF, the greatest common factor, from each row and column, I'm going to get x minus 4. And then on this one, I'm going to get x plus 4. So your final answer will be written as x minus 4 times x plus 4. No, you can say x plus 4 times x minus 4. Yeah. All right, let's take a look at the next one. Very similar to what we're going to do on the last one, except we got a y squared chilling out here. Okay. We learned last week that if we have no b term, then what's going to happen is we can actually take the square root of these two terms and then write out our factored form. Okay, so what I mean by that is, what's the square root of x squared? X. So that means that in my parentheses, I'm going to have an x here and an x here. What's the square root of 9? Okay, and then what's the square root of y squared? Okay, so I'm going to have an x plus 3y and an x minus 3y. Okay, so again, it's the same thing that happened up here. We just did it the longer way. So I'll show you how this works. If I take the square root of x squared, I get x, right? That's why I have these x's. If I take the square root of 16, I get 4. So that's why I have these two 4s. Okay, one of them has to be minus and one of them has to be plus because we have no b term. Okay. All right, on the last one, same thing's going to happen. I'm going to take the square root of both of these. What's the square root of 4? 2. What's the square root of x squared? Okay. What's the square root of 25? Okay, so we're going to get a 2x plus 5 times a 2x minus 5. Okay. Let's take a second. Are there any questions? Today we're going to be talking about extending polynomial identities. Okay, extending polynomial identities. Okay. So the difference of squares. Notice in the last 3 problems, each term is a perfect square, and you're subtracting them. Okay, we can use a squared and b squared to represent any perfect square, first and second term. Let's generate the rule using the area model. Okay, so really quick. Without freaking out about all the variables, okay, if I got a squared minus b squared, okay, what's going to happen is we're going to do the big X. We know that our b term is 0, okay, and then we have our a term times our last term, which is ab. Okay, so when we write this out, it's going to be 1. Yeah, 1. Okay, on this one? No. A would be 1, B, last one would be 1. So this would be negative 1. Yeah. Okay, so when we actually factor this out, this is going to be A minus B and A plus B. Okay. So right here in this box, this is going to be minus AB In this box, we're going to have positive AB. Okay, so the rule for this, again, and we talked about this last week, was A minus B times A plus B. Okay. I don't remember my perfect squares. Okay, so difference of squares. If you see a binomial with subtraction, check the terms are perfect squares. Remember, you could have a GCF. So what are my perfect squares really quick? Okay, like listen them out. What's 1 squared? Okay, what's 2 squared? 4. 9. What's the next one? What's 4 squared? Okay, what's 5 squared? What's 6 squared? What's 7 squared? 8 squared? 9 squared? 10 squared? 11 squared? And 12 squared. And you can keep going. There's not just 12. Okay? So what you want to do is you want to check and see if they're perfect squares. Well, we know that this first coefficient is going to be 1. Okay, so the square root of 1 is going to just give us 1. And the square root of x squared is just going to give us x. What's the square root of 81? Okay, so we're going to have an x plus 9 and an x minus 9. And the reason why we're going to have a plus and a minus is because there's no b term here. Okay. On this one right here, what's the square root of 121? Okay, and what's the square root of x squared? X squared. Okay. And then what's the square root of y squared? Okay, so we get 11x plus y and 11x minus y. Okay, 18x squared and negative 75. Neither one of those is a perfect square. But both of these are divisible by a common factor. What are factors of 18 that are also factors of 75? 3. So if I divide both of these things by 3, what am I left over with? 18 divided by 3 is what? Okay. What about 75? Can we break these down anymore? Can we take the square root of either one of these? Which one? Can we take the square root of 6? Is it going to give us a perfect, or is it going to give us a whole number? Okay. So when we take the square root of 6.
First period teachers at this time.
Okay, so when we take the square root of 6, what we're going to get is still just the square root of 6. X. When we take the square root of 25, what do we get? 5. Okay, so we're going to have the square root of 6 with an x out here plus 5 times the square root of 6 x minus 5. And we're going to leave that 3 out front. Really, we should put this x in front. We're actually going to write this x out front. I apologize. It's a little messy, but okay, take it. Okay, so we're going to have x square root of 6 plus 5 x square root of 6 minus 5. Again, the reason why we're going to leave this as a square root is because when we take the square root of 6, we don't get a whole number. Okay, and you can't write these out in decimal form. You have to leave them in radical form. And further, so simplify the expression. What's 4 plus 3? Okay, not a trick question. All right, 4 minus negative 3.
7.
7. So what do you notice? Because a negative and a negative makes a, okay. They both end with 7, right? Okay. Now, when we look at this, we're going to rewrite the following as a subtraction instead of addition, and then factor the difference of squares. Okay, so again, we're going to write this as a subtraction instead of addition. Okay, so how are we going to write this? We're going to say x squared minus negative 81. Okay, and we're going to rewrite the following and then factor the difference of squares. Okay, so how are we going to go about doing this? We're going to factor. Okay, so let's use the box. Let's use the box. Okay, so we get, okay, let's do the square root then. When we take the square root of x squared, what do we get? Okay, when we take the square root of a negative 81, what do we get?
-9. No, 9.
Think about what we did yesterday.
What is that negative under the root?
So I'm asking you for negative 81, right?
What is that?
Okay, so there's going to be a plus 9i. Maybe minus 9i, but then that would cancel out, right? No, make it positive because it would have I squared. Mhm. Yeah. Yep. Okay, so when you do this, we're going to rewrite it as a subtraction and then take the square root, like just like what we did. Okay, so we're going to rewrite this as x squared minus negative 121. And then what's the square root of x squared? X. And then what's the square root of negative 121? What's square root of 121? 11 with an I, right? So we got x plus 11i and x minus 11i. No. Yeah. All right, go ahead and try number 6. Okay. So when you take the square root, I'm sorry, we're going to rewrite this first. 4x squared minus negative 25. Okay. When I take the square root of 4, what am I going to get? 2x. When I take the square root of negative 25, what am I going to get? 5i. So I'm going to have a plus 5i and a minus 5i. Okay. Are there any questions on this?
Okay, so if I did it backwards, like I did plus, what's still good?
You did what?
I put the minus sign first, then the plus.
That's fine. What do you mean? I mean, it would be like written like this. It would be like 2x minus 5i times 2x plus 5i. It would be the same thing. Yep. Okay. So let's go ahead and get some practice in. Shh. Wait, no, y'all. Okay. So what I'd like for you to do, okay, is you're going to take what's on the left-hand side, okay, and you're going to match it up with one of these columns.
see that.
Okay, I'll zoom in.
Oh, not like, I'm talking about.
Yeah, y'all don't have, I don't think y'all have this on your paper. Okay. So I'm gonna zoom in on it. Okay, and I want you to do the first 4, and then we're gonna go over it. Okay, so again, you're gonna take what's on the left-hand side and match it up with its factored form. Okay, now there's some other stuff over here that you can also match up. Okay, so anything that's not in factored form, you need to put it in factored form. Okay, so on your paper, I want you to try these 4, and then we're gonna talk about it.
What about, the ones on the side of it?
Let's start with these 4, and then we'll talk about those. Yep. All right, so go ahead and take a moment. You're trying those. Let's check in on 1 and 2. Ready? So on number 1, when we factor this, we're going to get x minus 3 and x plus 3. I'm sorry. Yeah. No, that's right. Nope, just kidding. I'm just kidding. It's not that one. X plus 9, x minus 9. Okay. On number 2, when you take the square root of this, what's the square root of 9?
3.
Okay. And then we've got the square root of 64. But remember, since this is a plus sign in between, you're going to write this as a negative 64. Okay. So a negative 64 is going to give me what? What's the square root of negative 64? Okay, 8i. So you're going to get 3x plus 8i times 3x minus 8i. So it's going to be this one right here. Okay, on number 3, we've got this negative chilling out front. 2 is this one down here.
Oh my God.
No, I'm not gonna let you
Grab it.
Go to sleep or something.
What?
I'm gonna throw
What?
the computer.
Now we can take the square root. What's the square root of 4? 2x. And then what's the square root of negative 9? Okay, but since there's a negative already here, we're going to have a plus 3 and a 2x minus 3 with that negative 10 out front. Don't see where you have that on here though. Might be a little bit further down. Yep, right there. Okay. All right, so the last one right here, we've got x squared plus 81. Okay, when we do this, we're going to rewrite this as x squared minus negative 81. So when I take the square root of x squared, what does that give me? X. And then what's the square root of negative 81? 9i. So we're going to have x plus 9i and x minus 9i. Okay. Yeah, that one. And that one's this one. Okay, so going back to our PowerPoint, you got one more question that I want you to do, and then we're done for the day. Okay, so what I'd like for you to do is fill in the boxes to make the equations true. Okay, now I think there's more than one right answer on this one. Okay, but fill in the boxes to make the equations true. Okay, so take a moment, think about it, and then we're going to talk about it in just a second. There might be just one. Okay, if I have 3x right here, then I'm going to have what right here? A 3x. Okay, good. So hopefully at that point you got that. What about right here? What should I put? 7. Good. Okay, so if I take 3x and I multiply it times 3x, what is that going to give me? 9x squared. And then if I multiplied 3x times negative 7i, that would give me negative 21i x. And then if I multiplied 7i times 3x, that would give me positive. That's why that cancels. What's 7i times negative 7i? 49. Voila. Okay. So this week, our goal is for you to make sure that you're good on factoring. Okay. So if you did not finish your Delta math last night, shame on you. But if you are able to get that done, make sure that you take care of that. Okay.